y is equal to 1, when you flip it, 1 over 1 is still 1. So that's going to be a point. Right? So I'm going to do another point up here at about 180. Another point here at about 270. Right? On the bottom, where is it going to be at the bottom and why? Yeah, go ahead. Pourquoi? Same rules apply. If you start with negative 1, that equals 1 over negative 1, right? They have the same value. Okay, so there's going to be a point here at negative 1, which is down here someplace. Negative 1. Is this easier to see on like this? I think it is in yesterday, right? Is it much easier to see? That was the idea. All right, so we're getting very, very close, but we're not quite done. We did our asymptotes in there. Okay, and we did the shared point. Now here's the last part. I wasn't really clear on this yesterday. We can, in order to get the rest of the shape of the graph, we're just going to take the reciprocal of a point. So if I'm using this top point right here, which is 4, what's the reciprocal of 4 going to be? 0.25. In the fractional form is 1/4. Okay, so I'm going to go down here somewhere like 1/4. Okay, it's approximately 1/4. So the point was this was 4 goes to 1/4. Okay, because remember we're flipping everything, right? That's right. Go ahead. No, yeah, the 45 points stays the same, like the x values stay the same. It's just the y values that we're flipping. Okay. Now let's look at the bottom here. Since this is negative 2, what's the reciprocal of negative 2? Negative 1/2. Okay. And do your best to be accurate. I mean, you can't make it perfect, obviously. Okay, but do your best. If we wanted a perfect graph, we use supercomputers. Okay. Or Desmos, right? Just negative 1/2, because we start here at negative 2. And it's going to go to 1 over negative 2. Okay. How do we finish now? Connect the dots. Okay. So I'm going to connect the dot here. This graph is going to go something like this. Now this is where we need to stay awake. How is it going to finish after that? Not touch the asymptote, right? So it's going to be just like that. Remember that exponential graph, right? Like the kid with the hockey board. It's the same idea. So this is going to slide up. This is called a hyperbola. It's not quite a parabola, but it's parabolic and like similar to the parabola, right? Where it's going to get bigger, like a U shape. Okay. The same thing over here. So somebody, this is going to repeat here. Remember, this is a periodic graph, right? So this is going to repeat forever and ever and ever. As far as the bottom graphs, what's the bottom graph going to look like? Someone other than Alex. What's the bottom graph going to look like? See your hand signal? Yeah, so I heard couldn't do this, which is what it's going to be. Okay. It's not going to be a circle or anything weird. It's just going to be sort of curvy and look just like that. Can I tell an embarrassing story about your brother? Okay. I was doing a graph like this, and he said, Mr. Sadler, I really like your curves. That came out wrong when he said it, obviously, when I said it. But he did actually say that, right? And I was, yeah.
So the reason why we can't touch that asymptote is because we can't divide by 2.
Right. All right, so that's what that's going to look like. Sorry. Yeah, go ahead, someone. I'm just one stack. Sorry, I can't. Generally, it's going to be right. So it's whatever this point is the max, right? It's going to just be right underneath the max, right? So it's going to have the same x value, right? Okay, so this is what I'd like you guys to do right now for the next 5 minutes. I'd like you to try the second graph yourself. Okay, you guys can do this hopefully right now. Okay, you need a piece of paper, I bet. Okay, but unless you, I'm going to save this somehow. So if I'd like you guys to try the second graph, where's my video? Right now. All right, so I'll get system started here with the asymptotes here. So the asymptotes I'll do green this time. Now, as you can take a look as you're going through here, the asymptotes don't have to be equal distances apart, right? Like you can see on the positive numbers, it's very, very wide, and on the negative, it's very small, and that's fine. good comment here by Leon. He said all the positive asymptotes should be the same and all the negative asymptotes should be the same, right? Because this is periodic, right? So it should be the same pattern. All right, so what I'm going to do then in blue this time is I'm going to say my common points are going to be at 1. And negative 1. All right, let's do the top half first because that one's a straightforward one, the bottom isn't. What's my other point in blue going to be? Oh, and go. 1/3, okay? Because this is a 3, it's going to be 1/3. 1/3 is going to be about here someplace in the top. Oh boy. Okay. And I'm going to do the top. I'm just going to connect the dots on the top half. Please remember to put arrows here. On all, because we do actually continue on forever. Getting more infinitely close. Yeah, it's almost meaningless. Okay. All right. Can someone other than the people I've told the answer to give me a suggestion of how the bottom is going to look and why? Yeah, go ahead.
You got another point that's like first you'd be like the negative 1/2.
Yeah.
And then you just flip it over so it'd be negative 2.
Okay.
So it's like you're not finding the vertex, it's already finding.
Right on. So if you heard what he said, then that's very good. What you're going to do is you're going to pick another point on here, which is 1/2. Negative 1/2 goes to negative 2. Okay. So the thing that happened in this graph was that these just happen to be your maximums. Okay, so the point I gave you is like the top of your parabola going down there. Okay. And there's your graph just like that.
And that would only happen if it was if we're at a negative 1.
Right on. Yeah. Yeah. Someone line?
So we still start at -1, you just type out the negative.
Exactly. Yeah. Exactly. And you can pick any point. If you want to pick like 1/4 or 1/3, whatever, you can pick 1/4 just here, which is going to be negative 4, right? So 1/4 here to negative 4. Just always in the flipping opposite direction. All right, I'm going to leave number 3 for you guys for homework. I'm going to do number 4. Excuse me, as a class. All right. Let's save this. Okay. Whoops. Hello. Oh no. So example 3 is going to be yours for homework. Looks like it's not going to spin for me. Here, we'll do example 4 here though right now. All right, this one here is a little bit different. Why is this question different than the other 3 that we've seen today? Yeah, Grace? Yeah, everything's a positive here, okay? Everything's going to be positive. Let's try and follow along the same idea. So what's the question? Or? Yeah. Depends on what I said you graph from, right? I can say from here, but if I were to say from 0 to 360, that'd be fine. But if I, you know what I mean? Otherwise, that'd be okay. All right, so let's start off here. What's the first thing I do there? I have my graph that it's already graphed. What's the next step, please? Sorry, listen, I want to get everyone a chance here. Sorry. Summary or out too. Go ahead. Asymptotes here. So our asymptotes here are going to be a little bit different. I'm going to give this in green. This is going to be here in the middle. So even though this graph just touches the line 1, 6, 0, you still put the asymptotes in here. Marissa asked a good question. I don't know if everyone heard. She says, well, how far should we go? I drew this graph a little bit to the left of 0 and a little bit to the right of 360, just so you could, see those points. But generally, if I were to say graph from 0 to 360, that's all you'd have to do. All right, somebody else here, please. What's the next thing I should do on this graph? Yeah, Quinn, go ahead. Yeah. So the thing is, for this graph, it's a little bit different. There are no negative points, so there's no negative shared points. So I'm going to put my shared point at 1, which is going to be right there. My shared point at 1, which is going to be right there. My shared point at 1, which is going to be right there. My shared point at 1, which is going to be right there. My shared point at 1, which is going to be right there. No, I'm done talking. Okay. Next comes what? I'm going to pick on you. So you've been seeing so 5 days back all semester. What comes next? Good. Okay. So this point is 6. What's the reciprocal of that going to be? 1 over 6. So you're going to ask me that's very close here to the 0. Not quite touching the 0, but very, very close. Okay. Now the reason I wanted to do this one for you, not because it's super difficult, because I think once you do a few of these, you guys can handle it, right? Like it's not meant to be overly difficult for you guys, okay? But you have to see it. If I were just to give this to you blindly, you'd say, did I do something wrong because this one's different? All right? So, we connect the dots and we're done. So what happens when people see things that are different, they're afraid? Yeah. Because this is the only graph we've seen say there's no negative, which is okay.
Why can't all graphs be positive?
Some of them can.
Yeah, but it's a big downward if you have negative slope.
All right. On that note.
Unbelievable.
One other thing I should note that I don't know if anyone noticed with this graph. Before I continue with the rest of the second half of today's lesson here, okay? So please go. So it says, what's different with this actual graph? It says graph y equals -3 cos 4 theta plus 3. What's different about that? Yeah, -3. So if you look at the way this graph goes, it's going to start at the axis, which is 3. A positive line is going to go upwards. A negative sign is going to go downwards. All right, so it's just going to be a flip. So if you think of how sine normally looks, right, just a reflection of what it's going to be. Okay. Yeah.
The same sign, not negative?
No, negative sign.
Is that same with cos?
Yeah, same with cos. No, yes. So cosine starts at the max. Negative cos will start at the min. Right, because it's like times -1. Yeah.
At the end, do we have to draw that middle one too?
No, probably not. Probably not. Okay, good. All right, I'm going to do a little mini lesson here for the last maybe 15 minutes or so. Your homework night is going to be example 3, which should take you not too long at all. And then we'll move on to... So what I'm going to do, if you missed... Whoops, sorry. If you missed... where'd it go here? Hopefully it's still here. I'll leave that up there if you missed it.